My name's Dion Alfonsi. I'm one of the co-authors of the WAmaths series, and I'm currently the head of maths at Shendon College, so obviously a Western Australian school. Today I'm going to take you through two chapters and the critical features of, I suppose, what's common to all of the chapters in the text. But just before we begin that exercise, I just want to give you a bit of an insight into what the kind of design program was for this text. So the philosophy of the text is really around what makes a student successful in a mathematics exam and how can we use those considerations for a textbook, which is quite different to a textbook which is just designed to learn and consolidate what gets taught in class. So it is a backwards designed textbook whereby we're looking at the end result for a Year 11 and 12 course and working our way back to the teaching as the starting point for those successful exam students. Today, what I'm going to do is I'm going to highlight the key features of two sample chapters and what I would consider to be the benefits for both teachers and students of those of this book. I'm also going to highlight points of difference whereby, especially for these two topics of statistics, which if you all have experience with the 12 methods course, we know can be quite complex in how we teach and how students learn and how it gets assessed in the WACE exam. So I'm going to take you through some of the key features as the author of these two chapters that I've tried to embed within these two, within the content of these chapters. And I'm also then going to take a second section whereby we're looking at what are the key aspects of this book that really promote that idea of examination success. So throughout my slides, you'll see a couple of logos that pop up. So the first one is the benefits of the teacher. If you see a box that refers to the teacher teaching, that's my interpretation of what's beneficial for the teacher. Same for the student. But you will also see a couple of instances whereby I've put an exclamation mark, which I'll talk to why I think this textbook is different and what benefit I think it serves, especially in these two chapters. Okay. So like as Susanna said, if there are any questions, please pop them in the Q&A and we can refer to them a bit later on. And I apologize if I go through this quite rapidly, but obviously you'll have access to these slides later on. So in terms of the structure of the chapter, we've got obviously our contents pages, and I'm not going to address these two chapters in chronological order as they're presented. I'm going to just base it on the features of the text and then take examples from different parts of the textbook. So don't feel like I'm teaching you the content in the order that you would teach it in class. I'm just going to jump around a little bit based on the features. So very, very clear outline of what kind of content would be covered in these two chapters, very explicit and very, very much aligned to the language in the syllabus. And the other benefit here is that the syllabus is actually provided to the students in the book, which is a nice way for in using the book. Every time you're teaching something, you can use then the syllabus as one of your teaching tools. You can go, okay, we're covering this chapter today or covering this exercise today. Let's go back and look at what is the language of the syllabus. And it really enables the students, one, to access all of the documents for the syllabus in one resource rather than having to go between a SCARSA document and their textbook. But also it enables them to become masters of the language in the syllabus, know exactly what it's referred to when we say use relative frequencies and histograms obtained from data, and they can see how relevant the chapter and the content is to what's being asked of them in the syllabus. Now, Dirk will speak to the MindTap platform a little bit later on and what the purpose of that is, but you will see that underneath each chapter identifier on the page of the textbook, you've got a link to or a reference to some of the online resources that are available through the MindTap platform. And at the start of every chapter, you've got a reference to what's available for this chapter online as well. Now, within each sub-chapter, and I haven't screenshotted all of them, but within each chapter, there's very, very clear subheadings as to when a new part of the content begins. And both for a teacher and a student, you can imagine as a teacher going through this content and working out what part of the book is going to be relevant to the lesson that I'm delivering today. It's a little bit more friendly in terms of, okay, I'm actually only dealing with this part of 8.3 today. And also as a student that's using this textbook independently, perhaps at home or in class, they can really then go back and reference what part of the textbook that was from. One thing that I will say that I will talk to as a significant point of difference a little bit later on is that aspect of confidence intervals and for proportions. I have kind of tried to really make this section quite significantly different to what exists. And you can see there that idea of interpreting confidence intervals and examining claims and historical data and comparison of samples, which is nowhere mentioned in the 12 methods syllabus if you look carefully, but it has a tendency to come up in past WACE exams in some form or another. Okay, so I will allude to those a little bit later on. Now, when introducing content to the students within the book, anything that is significant and it deserves to be a glossary term, it'll be highlighted in blue. And where these terms are introduced, we often try and support it with a diagram if it's appropriate. But the key language is often written in blue. There can be terms that are written in black and bolded in black. That would suggest that the terminology is important, but it's not important enough to be a glossary term. It may be a term that they've seen before, like mode is going to be something from their Year 8 curriculum that they've seen, Year 7 curriculum. So it's not necessarily specific to a SCASA glossary point. And if you see this CO8 or CO9, that's just me referring to the fact that I've pulled this example from chapter 8 or chapter 9. Now, in some cases, there may be points or topics whereby there needs to be a link back to a previous chapter. So for example, we know in 12 methods, we look at changes of scale and origin in the discrete random variables chapter, and then we do it again with continuous random variables. But even something simple like introducing standardization as a process whereby it really is just a change of origin and a change of scale, rather than just a formula that says score take the mean divided by standard deviation. Trying to find those really conceptual points whereby instead of just me teaching a process to find a standard score, you're doing a score take mean divided by standard deviation, making those links between what they've already learned in the year. So understanding that there may be a different way to teach this content as a teacher, but also a different way to understand it as a student as well. And as I mentioned, the blue is generally what's going to be referred to in your SCASA glossary, but it's not limited to that. So there may be some terms that I've felt and the authors have felt to be quite important, and they haven't been referred to in SCASA glossary, so they can still be written in blue. But it's one of those distinguishers that you're going to have to make as a teacher as to the importance of that term that you place on your teaching. Okay. And the language, I don't know if you had a chance to read through all those, but hopefully you've had a look at some sample pages, but the language throughout the chapters is quite student friendly and quite teacher friendly as well. So it's not written in a way that's purely academic and university level. It's written in a way that it's conversational. It should be conversational as a student is reading, and they should be able to imagine that their own teacher, or yourselves as teachers, saying that to them as you're teaching. Okay, so it's not written verbosely, it's not written convolutedly. It's quite conversational when appropriate. So even things like justifying a normal distribution as appropriate or not, that idea of these are the conditions, or these are some examples, this would be appropriate, this would not be appropriate. Now, all of those blue terms are then referred to in a glossary/index at the back of the book. So it's a glossary because it's got that definition associated to it, but it's also an index because it's got a page reference, which makes it nice and easy for the students to go back to the page and the content that it was relevant to. Oops. And in addition to those key paragraphs of content explanations, which yes, every textbook has got, quite a nice distinguishing feature of the WAmaths series is the summary boxes. So the summary boxes are those really nice snapshots. It can either be at the end of a chunk of text, it can be at the end of a chapter, it could be halfway through an explanation, but it's that idea that, okay, we've encapsulated something quite important here as a piece of learning or a piece of teaching. And even if as a teacher that's maybe teaching this topic for the first time, it may give that you as a teacher an idea of where do I really need to make my key teaching points, and what isn't essential for the students to walk away from this chapter with. So for example, if you're talking about cumulative distribution functions, yes, process is important, but that understanding, again, linking back to earlier topics in 12 methods, the understanding of the inverse relationship between differentiation and integration. And that is something that's quite significant in the studying of continuous random variables, knowing that a probability density function is the derivative of a CDF, and a CDF is the integral using your fundamental theorem of calculus for a PDF, okay? So again, making that link to what they've already heard and seen, but making it clear and precise within a summary box. Now, summary boxes may be formula-based, they may be explanation-based. We do often have maybe a point in a summary box that extends upon a little bit of what has been summarized. So for example, you can imagine after discussing whether it's appropriate to model a binomial distribution with a approximate normal distribution. So we've discussed it in the chapter. We've got a nice summary here of what that would look like as an approximate normal distribution. But then there may be some further advice to both teachers and students to link it a little bit further what they may see. So for example, there's nowhere in the syllabus, and nor are students really expected to justify normality by using NP greater than a certain value. Some books do 10, some books do 20, 30. But where appropriate, we've introduced those kind of things that students may like to use as further checks, even though they're not essential in the syllabus. So, and again, I've led into this discussion with some mathematicians like to put a minimum condition rather than leaving it vague as having a sufficiently large n. So just that leading to a discussion that even if you don't address it as a teacher, the students might go, "Hey sir, can you explain what this is meant in this summary box and why it's there?" It may lead to some further discussions in the classroom. Now, a point of difference that I would like to discuss is just that process through that approximate normality of a sampling distribution of sample proportions, which is a very big part of your chapter 9. And we know it causes, or it can cause, a lot of confusion for students, a lot of confusion for teachers, knowing how far to go with it. And a lot of a misunderstanding when we get to that idea of a confidence interval. So again, a summary box may be a completely separate point that summarizes not only what they've seen in the text, but again, that little bit further, and a provision of advice to students as well, other than what we call an exam hack, which I'll show you a little bit later on. So where possible, if within a summary, I felt that it's appropriate to give that little bit extra, that may advise students of what they can do. So example, when we're looking at a approximate normal distribution, another way of checking whether n was sufficiently large enough, instead of doing an NP and NQ check, is to think about, well, if I'm doing a normal distribution, I'm going to want my p hat values to be within 3 standard deviations. And I don't want any negative p hat values, and I don't want any p hat values greater than 1. So providing another way for students to sensibly make sense of the content and the concept that if I'm going to approximate something as normal, I can't have it go beyond the bounds of 0 and 1 as a sample proportion, because that would imply that my n was not sufficiently large enough to balance out the skewness that may have come from p hat. So again, giving those opportunities for discussions around the concepts behind the approximate normality of a sampling distribution. And the other point of difference that I felt when doing a bit of analysis of the textbooks that exist for 12 methods is that engagement with the point that involves what it means to have a confidence interval. And we know, if you've been teaching 12 methods for a little while now, we know that the definition of confidence interval actually changed in our methods syllabus from the initial iteration of the course to the iteration of the course that exists now. We went from a probabilistic Bayesian interpretation of confidence intervals that was all about a probability, to now the frequentist interpretation of a confidence interval, which is about the long run relative frequency of how many confidence intervals that haven't been constructed yet do we expect to contain our true population proportion. This is something that has been significantly confused in the teaching of confidence intervals. So I've tried to very, very clearly and very, very specifically outline what does it mean? And you don't have to go into the language of the frequentist versus the Bayesian perspectives, but it gives that little bit extra to this text whereby students can then go investigate and research themselves. What does a Bayesian perspective of a confidence interval, which is actually called a credible interval, mean in comparison to a frequentist interval? So again, I've tried to make it very, very explicit about what are the key learnings and the key things that students need to understand about the repeated construction of confidence intervals. And again, that idea of confidence intervals, once I take one, and this is again something that may not be explicit to the students, once I take a confidence interval, once it's constructed, it either does or doesn't contain the true value of P. So we can't comment on the likelihood that P is contained within an observed confidence interval. However, if we were to construct, that is future tense, if we were to construct confidence intervals and do a certain number of them of a fixed sample size, then we can expect in the long run that, let's say, 95% of yet to be constructed 95% confidence intervals would contain the true value of P. And it really engages with that nice statement in our syllabus that says most but not all confidence intervals contain P. But that discussion around yet to be constructed versus observed is something that may be omitting from past texts. And then the other thing that you may, if you've observed a couple of 12 methods exams in the last couple of years of WACE, there's that sneaky question that is not alluded to anywhere in our 12 methods syllabus that comes up around the comparison of either a sample to a claimed value of population proportion, or in fact, two samples. Now, I've tried to, where possible, give some scaffolded language and scaffolded advice to how students can think and phrase what it means to compare a claimed value of a population proportion to an observed confidence interval. And I've used language that is inspired by a higher order concept of hypothesis testing, which is not something we do in the Western Australian curriculum. It is in an Eastern States curriculum and it is in university mathematics. We don't have it in our WA curriculum. And really the comparison of confidence intervals to values and other confidence intervals actually means nothing if we're doing it without hypothesis testing. Yet students are being expected to make these kind of comments in WACE exams. And given that this text is has a philosophy of preparing students for exam success, it does need to be quite explicit in how it's addressed in the text. So there's a couple of phrases there that might give some discussion points, and I've tried to use the language of hypothesis testing, that is, there's sufficient evidence to suggest or insufficient evidence to suggest that you can or can't accept this claimed value of P. But the advice that I've provided in other parts of this chapter is you can't just write that statement. All of these comparison-based questions need to be written in context of the question. You can't just say it's not acceptable or the p-hat's not acceptable, okay? So those there are really just, as for teachers and students, ways to start getting students to think about what does this confidence interval mean, even though we don't have the formal concept of hypothesis testing. And I've done the same thing. So that previous summary box was about comparing one confidence interval to a claimed value of P. I've then done the same thing for when you're comparing two or more samples with each other. And again, try to, without needing to go into hypothesis testing, find ways, and what I've tried to do is take inspiration, take learning from the WACE exams and what they've expected of students to say. So when it's been appropriate to compare overlapping confidence intervals, if there's no overlap, what that means, if there is an overlap that is mutually containing another sample proportion versus something that overlaps but doesn't really mean anything. So just making students aware of that broader idea of comparison and when it's sufficient evidence and when it's not sufficient evidence to make claims and make conclusions. Now, because that's been such a significant part of the summary boxes and the content, I've made sure that there are plenty of opportunities in the actual chapter for this, for them to practice these comparison of claims, comparison of samples, which is not done thoroughly in other books. Other books tend to refer to level of significance, statistically different. That's not what we're referring to here when we're talking about the comparison of confidence intervals. There's a very common misconception that statistically different is what we're looking at here. It's not. We're not going that far. So we don't expect students to use that language of statistically different samples. We're just expecting them to make an inference about what comparative confidence intervals mean without that. So hopefully that's given you a bit of insight into the depth of that very difficult and very complicated topic that we don't have much clarity on when it comes to just relying on syllabus points alone, but we know what's come up in the WACE exams in the past. Other key features have been, are rather, worked examples. So the worked examples are throughout the whole text. Where possible, we've tried to support anything with diagrams and made it quite clear what those diagrams are representing. They're fully stepped out, fully instructioned steps to students in student-friendly language. Where necessary, we've given annotations that may not necessarily be part of the essential working out. So you can see in that example there, where we're looking at the expected value of a continuous random variable. So knowing the graph of this is not an important part of the question, but where it's relevant to something else in the text, it's been provided as an annotation, just again to help that student thinking and promote that student thinking. And not all worked examples, obviously we know in these two chapters, students have to write a fair bit when they're doing that statistical inference or talking about the bias in random samples. I've tried to model that, and all of the authors have tried to model what is the best practice for students in how they respond to these worked examples and these questions. And you'll notice that in the language of the worked examples, it's exam language. They're written as test style questions. It's not state one bias point or source of bias. It's identify and explain, which is something that's been written in the WACE exam before, or suggest a random sampling procedure. All of that is language of the syllabus. It is not simplified in any way. Okay. Now, after that content, so all of that is really about the content, the explanations, the summary boxes, looking at key features of that worked examples. And now it's time for the students to practice. So every subchapter rather, has a mastery section, which within that mastery section, they get a direct replication of a question that was a worked example. And it's referenced what worked example it's coming from. So for example, in that one that I've called worked example 3, which is about the bias, they then got another one to try whereby the language of the question is exactly the same. Identify and explain, suggest and describe. Okay, that one I've made a little bit more elaborate with the suggest and describe, but it's that same concept that they get to practice again. And yes, my worked example only had one context, but now I've given them 2 to practice that concept with. The other really strong feature of this is a lot of textbooks that I've seen have CAS involvement. So there is screenshots and there are instructions to how to use the calculator, but they've never been incorporated within exercises. That is, it's always, oh, here's a preamble to this chapter of how you would do this question calculator, but there's never a prompt to practice it with the calculator. And I know from my experience, if I don't teach it in class, the students aren't going to read a worked example or read an explanation of how to use CAS. However, if there's a CAS style question, they're kind of in a way forced to practice that calculator skill. So one thing that I really liked with these CAS examples in this chapter is I got to show students how they can use the piecewise define function to define a continuous random variable, and then they get to practice it and how they can be efficient with their calculator if they see a question that has 3 parts to it and all of them are using the same CRV. And then again, we know there's such a big topic of 4.2 and 4.3 is that linking between simulating random samples using technology. And one of our syllabus points actually says use graphical displays from simulated data to discuss distributions such as binomial, normal, uniform, etc. That is actually an important part of this course, and books just tend to do it as a bit of a read this exercise. So again, I've incorporated some using CAS examples, and you might have seen from the contents page, there was quite a few of them, whereby students get practice at observing what that data simulation process means. I mean, it's a syllabus point. Technically, it can be assessed. Has it ever been assessed? No, but I think that's a shortfall of the WACE exam, given that there's such a strong discussion that can be had around simulated data. And then the other really strong point of difference that I've thoroughly enjoyed working with in this text is the distinction between calculator-free questions and calculator-assumed questions. No other text has distinguished between what would be calc-free and calculator-assumed, other than in those one-off examples that say use your calculator too. This is very, very explicit. In every chapter's exercise, there is calculator-free, calculator-assumed. It really helps the students understand what kind of questions can be asked for this topic in a calculator-free section. And where possible, we've tried to use the SCASA WACE exam questions to take inspiration from, if not adopt fully, but this example here that I've given you is a modified, and you can see there in the title, which the students will see as well, it's a modified WACE exam question, because there may be something that we've taken out because it's not relevant to this part of the text, or it may be something that we've added in, okay? But the students can see that that would be a suitable calculator-free question. Now, every single waste question from 2016 to 2021 has been included somewhere in this book. And as I showed you before, some of them could be modified. Others we haven't touched. So for example, this one here, you can just see that I've incorporated that whole question. And then that way students are seeing how it's being assessed or how it can be assessed as they're learning. Now, obviously, if we were just to use the WACE exam questions as our only questions in these sections, we'd run out of questions pretty quickly. So where we've felt that there hasn't been sufficient or there's been gaps. So for example, I referred to the gap in simulated data as an exam question that hasn't been assessed in the WACE. I wouldn't want to trust that it's never going to be assessed in the WACE. So again, here's a question whereby that engages with a variety of displays of histograms, of simulated data, and students have to respond to an exam style question that has been completely constructed on its own. It's not a past WACE question, okay? So where necessary, authors have supplemented with further exam style questions. Now, one thing I didn't mention was that the structure of each exercise actually doesn't start with mastery. It starts with the recap section, unless it's the first exercise of that chapter. So an exercise 9.1, for example, won't have a recap section because it's the first exercise in that chapter. But 9.2 and 9.3 will have a recap section. And the purpose of the recap section, it's 1 or 2 questions, typically 2. And it's not solely multiple choice, but it's the place where multiple choice questions can occur. And these questions refer back to the previous exercise. So the first two recap questions in 9.3 go back to looking at the sampling distribution of sample proportions. Now, multiple choice is not something that's assessed in the WACE, and I fully understand that, and we as authors fully understand that, but they can be really powerful lesson starters or lesson conclusions that students can or teachers can use to discuss the reliability and reasonableness of solutions. So you could screenshot this and put it up on your slides and start your lesson with it and say, okay, let's have a discussion. Which one of these is not reasonable and why? And then it's really helping that mathematical reasoning that we know that students are being asked more and more of in exams, explain, show, etc. Now, at the end of each, this is the last key aspect of the text before I go into that exam aspect of exam success. The chapter summaries, so at the end of every chapter, and it's not a new feature of a text, it's quite common, but what is nice about the chapter summaries here is that every key point that was referred to as a definition or as a glossary term or a summary box has then just been concisely put in at the end of the chapter. So all of the glossary terms that I've identified in blue or any of those bolded terms in black have been then replicated in the chapter summary with the associated key formulas. But the summary could also involve some dot points around the key descriptions. So understanding probability and non-probability sampling methods, which would have been much more elaborately explained in the chapter with all the methods, but a summary has been provided at the end. So hopefully you can get a feel for what those key aspects of the text are without talking about real exam success. But now I want to really hone in on a couple of features before I finish up and pass over to Dirk. A couple of features of supporting exam success. The most obvious would be the concept of an exam hack. So throughout the text, we've provided exam hacks, and they can take place in lots of different ways. They can be within a worked example. So if there's been something that students have worked on in a worked example, they will see that an exam hack has been provided if there's something they should be looking out for. So for example, in this one here, you're working with a quadratic PDF, and the exam hack has been, you actually know something about quadratics that doesn't require you to use integration. So thinking about prior knowledge, and these exam hacks, if you read the next one, may actually also invite students to think about exam strategy as well. So for example, we know that the uniform continuous random variables aren't on the formula sheet. So there's nothing to do with the expected value variance standard deviation of a uniform continuous random variable, which means that students will either be expected to use integration techniques, but the advice is being given here that you pay attention to the number of marks in a question like that, because If it's a 2-mark question and there's only a single command and you're not being asked to use integration, then having something like that on your formula, on your note or your own notes page is going to be beneficial to you in the exam. We know though, if it's a 3-mark question, that you're going to have to show some kind of process or an integration-based process to get that result. And a lot of the exam hacks have also, when not come from our authors' perspectives, have also come from the markers reports from the WACE exams. So anything that's been provided to us as feedback to students and feedback to teachers has been recast in a way of an exam hack. So things about talking about bias, for example, in this chapter has been a significant exam hack, because we know that just stating the name of the bias isn't enough if they're asked to explain it. We know that in the past that exam questions have asked for a construction of a confidence interval, but when it's 3 marks, why can't I just use my class pad to write down the confidence intervals as an answer? So again, that idea of if a 3-mark question involves the construction of a confidence interval, it's actually really important to show that line of working whereby the confidence interval is being constructed. And other tricks are such as if you get asked a trick question. So for example, which of the following confidence intervals are more likely to contain the true value of P? We know that it can be something that's asked, but it's a trick question. So if there's been trends in what's being asked, we can also then put that in as an exam hack. And the other thing that you may have noticed as I was going through WACE exam questions is the inclusion of mark allocations. So it's the first time in a textbook whereby we've got marks assigned to a question being asked. The mastery questions don't have mark allocations because it's about the learning rather than the exam strategy and the test style question. But otherwise, the calc free and calc assumed questions will have mark allocations. Now, they again make it quite nice that the answers at the back of the text won't have the full work solutions for them to see what the 3 marks and 2 marks mean, but the work solutions that Dirk will refer to on the MindTap platform do have those breakdowns. And it just gives a really nice approach for teachers to go, okay, everyone, let's look at question 14. You've got 3 questions that are 2 marks each, but what is it about that part C that's making it a 3-mark question? And why do you think it's 3 marks? And then you can have that discussion, that really rich discussion around what is expected of a student when they have a 3-mark question to answer versus a 2-mark. The second last feature that I'll be talking about, sorry for going so fast, is the WACE question analysis. So just before the last exercise in the chapter, there's been one WACE question that's been saved to be discussed. So what this section does is it fully deconstructs the WACE exam question. They get a highlighted version of the WACE exam whereby the authors identified key information, key command words, key terminology. And we generally try and get a WACE question that encapsulates a lot of the chapter rather than just a single aspect. So you can see this was that very typical 21 mark question from 2020. Not only do the students get to see it highlighted and annotated, but then there's advice to the students around what does it mean to read this question carefully and pinpoint what this question is asking them to do versus thinking about the question, how am I going to answer that question? And it just gives that bit of a lead in before they actually go and either try it themselves or look at the worked solution. Now, the worked solution not only will have the answer, but if it's something that's involved a worked solution that isn't just stating a numerical value, then they will be provided with the marking behaviors. So again, getting those students used to the fact that WACE exams and tests really aren't marked by have I got the answer correct or not. It's have I demonstrated the right mathematical behavior in my working out. And the very last feature is the cumulative exam. So it's kind of a replacement for the chapter review, a review exercise. Given that it's an exam standard book and it's designed to maximize exam success, a chapter review may not necessarily be the most efficient way to do that. So what we've done is at the end of every chapter, there is a cumulative exam section, which is broken into 2 parts, calculator free, calculator assumed. As the chapters go on, as the textbook goes on, the number of marks and the number of questions in each cumulative chapter, a cumulative exam increases, obviously, because it's cumulative. So for example, if we're looking at the cumulative exam for chapter 8, which is the second last chapter, this could have questions from anything in your previous chapters. And obviously now chapter 9's cumulative exam would have all of it plus a little bit more from chapter 9. And we've tried to model that exam structure of reading time and writing time, whereby the reading time is approximately 10 minutes of the writing time. And that's something that should be reinforced as students are doing these cumulative exams. And you might want to do it as a classroom exercise. Okay, guys, let's look at the chapter 8 cumulative exam. Everyone now has 4 minutes, no pens, no highlighters. Let's go through and read. And just modeling what it means to use that reading time effectively rather than them just flicking through the paper. And so really nice discussions that can be had around strategy. And the cumulative exams, like I said, and part of the whole chapter has been, it could be also another place to put a past waste exam question, but where it's lacking, where we've been lacking in waste exam questions, we've supplemented with our own questions as well. So it's not just another place for waste exam questions. We've tried to write some exam style questions to support. Great. Okay, I'm going to take a break from talking. I'm going to pass over to Dirk, who's going to give us a bit of a rundown into the MindTap as a supporting resource for this text.
All right. Thanks, Dion, for that. You can have a rest now. Okay. Nelson MindTap, as Dion just said, is the digital support for the books that he's been talking about, and there's a whole other side to this this combined product. It's part of the deal, basically. Nelson MindTap. So what is it? It's a lot of things. There's an e-reader there, which matches the textbook pages, so you can sort of know exactly where you are within the digital product as well. But it also has integrated trackable assessment throughout, and what we mean by that is it's things that students do that you see the results of, so you can actually see how your students are going by the sorts of assessment that they do through MindTap. It also allows you to assign tasks directly to the student or to the whole class. So there's it puts the teacher in control of what they need to, of what they would like to do, how they'd like to run things. On top of that, it has a huge number of resources, all linked to the textbook. Some of them Dion's mentioned briefly, and also you can add your own material to the learning path. So there's a lot of, it's quite a powerful platform, which belongs to WAmaths. As Dion mentioned, at the start of each chapter, there's this list of things that appear in MindTap. So it's always very clear to teachers and to students what's available. In this case, we've got some video playlists, some worksheets, and so on. And as Dion said, these particular things also appear in the margin of the textbook, so at the place of where they're relevant. So they appear twice within a chapter. However, this is only the pure student resources. So these are, students have access to these, but it's not everything. In fact, it's nowhere near everything. This is just sort of the start. So I'll talk a little bit more about those other things that are also available on top of those, as well as going in a bit more detail about those particular resources. Dion also mentioned the work solutions. Now, just to reiterate what that is, they are available on Nelson MindTap, and they are work solutions to every question in the textbook of any kind. And for those questions which have marks attached to them, which may be SCARSA questions or maybe the exam style questions, of which there are a lot of, have a marking key, the equivalent of the sort of thing that SCARSA does and what Dion outlined. So we have that. Here's an example of one of them. We use the student behaviours where relevant. Sometimes it's just the answer if it's just simply an answer, but the tick there always indicates 1 mark. So it's always clear from the work solution what a student needs to do to get full marks for a question. So it's much more than just a work solution to a question. The other feature that was mentioned in the, is listed in that student list, was the waste question analysis video, which as Dion mentioned, the waste question analysis appears in each chapter. There's one in each chapter, and it goes through in detail all of those things, like thinking about the question, reading the question, provides a solution, it highlights key terms and so on, all that sort of stuff. We recognise that may not be the most suitable thing for students to just read through, because it can be quite daunting and quite detailed. So we've given another opportunity for students to be able to sort of get to grips with this analysis by a video version of exactly what's in the textbook. So so we've got someone on screen talking through how you solve it, plus adding sort of hints and tips and so on about things to watch out for, which is something that students can pause if they want to, or they can go through, at their own pace. Plus, it's a different approach to their own teacher, perhaps, and it's certainly a different approach to just reading through a static text. So we felt these were really important, because this is sort of the crux of our focus on exam success. So that there is another way that students can look through these WACE questions and see how they can maximise their chances of doing well. In addition to those videos, we also have video playlists, and they are around 3, it sort of averages 3, sometimes it's up to 5 video options for every topic in the book. So that's about 100+ video links that are available, linked directly to a section in the textbook. Now, these are videos that are available on the internet. I mean, if you had 100 hours free time, you could search for them yourself, but we've tried to do that work for you. We've picked the best videos for each topic and each subtopic in the course, and given students an alternative in many cases, so that there are sometimes 3 ways of explaining the same topic in 3 different videos. And we all know that some students require a different explanation to the teacher's explanation, or sometimes it's just they want a different approach is suitable, and maybe they can listen to look at all 3 of them, and the different approaches together, they can make sense through it. But anyway, it's there to save you a lot of time and to give students that extra support to be able to come to grips with a lot of the topics. Nelson MindTap also has for each chapter what we're calling prior learning checks. They're multiple choice questions. In this case, you can see that's for chapter 7, that's one of 6 questions. And they are basically, as it says, they're trackable tests to see if students are ready to start the chapter. So again, these are when students do them, you'll be able to see the results. So you'll be able to see before the students start the chapter who is struggling, or whether there's something you've got to do in preparation to start a chapter. But also, we've done a bit more than that, because it is a teaching tool as well. If a student selects the wrong answer, it gives an explanation of why that answer is wrong, a succinct, clear explanation of what they've misunderstood. Plus, there's a full work solution to that question as well. So it is supposed to support the students to become ready to start the chapter as well, rather than just a summative assessment and saying, oh, okay, they're not ready. So that's the prior learning checks. We have worksheets, about at least 70, and they have extra. They give students extra skill practice, and there's answers supplied as well. So I won't say any more about the worksheets. I think you understand what they're about. We also have for each chapter a topic test, and that's assignable chapter tests in the format of mini exams. So these you have control of, like the work solutions I mentioned right at the start. They're in the teacher has control of when students see them, and like a test in this case, obviously you wouldn't want them to see them until you want them to see this. It's the same thing with the work solutions. You allocate that to students or to the whole class when you feel it is the right time to do that. So in this case, as I said, we've modeled them on the exam with the two sections. You've got a calculator free and calculator assumed, and it's as I said, it's a mini exam and fits in with our philosophy of trying to do whatever we can to make students exam ready. And lastly, I'll mention the teaching programs, because I know that when you switch to a new textbook series, this is one of the hassles that you sort of have to redo all your paperwork. Well, we've tried to make that easy, because these are fully editable teaching programs that you can adapt for your purposes, for a scope and sequence chart or whatever it is that you'd like to do with that. I'm going to now hand over to Donna to talk about sales and prices and things like that.
Thanks, Dirk. Thanks, Dion, as well. Hi, everyone. My name is Donna Hamlin, and I'm the Learning Consultant for WA South. Today, I'm just going to talk briefly on the pricing and availability. Availability is set for Term 4 of this year, 2023, ready for Back to School 2024. The new senior maths is offered as a print digital blend, incorporating both the book and the Nelson MindTap courseware. And this is available at $89.95. We also have a digital only option of the Nelson MindTap courseware, if that's your school's preference, and this is available at $42.95. We will work with you and the school regarding onboarding of Nelson MindTap. As I mentioned, I look after WA South, and my colleague is Glenn Watson, who is a learning consultant for WA North. Glenn and I are out at the moment visiting schools, so if you haven't already heard from us, please do reach out. We have sample copies, page proofs, and we're more than happy to call out and demo the Nelson MindTap with you and work through that with you a lot deeper. We also can arrange a complimentary sample trial of the Nelson MindTap courseware for you to explore. The best way to contact us is via email, and that's glenn.watson@cengage.com, or myself, Donna Hamlin, @cengage.com. And we are, as I say, we're out and about at the moment now. So if we haven't already spoken to you, don't be shy, give us a buzz. Thank you again for your time.